Projectile motion is a type of motion that occurs when an object is thrown or projected into the air and moves under the influence of gravity alone. It is a combination of horizontal motion, motion in the x direction, and vertical motion, motion in the y direction. This type of motion is commonly observed in sports such as basketball, baseball, and football, as well as in everyday situations like throwing a ball or shooting a cannonball. Key characteristics of projectile motion include independence of vertical and horizontal motions. In the absence of air resistance, the vertical and horizontal motions of a projectile are independent of each other. This means that the object's motion in the x direction does not affect its motion in the y direction, and vice versa. Constant horizontal velocity. In the absence of external forces, such as air resistance, the horizontal component of velocity remains constant throughout the motion. This is because there are no horizontal forces acting on the projectile once it is launched. Vertical acceleration due to gravity. The only force acting on the projectile in the vertical direction is gravity. Gravity causes the projectile to accelerate downward at a constant rate, approximately 9.8 meters per square second on Earth. Parabolic trajectory. Due to the independence of horizontal and vertical motions, the path followed by a projectile is a parabolic trajectory. The projectile rises, reaches its highest point, and then descends back to the ground. Symmetry. The time taken for the projectile to reach its highest point is equal to the time taken for it to return to the same horizontal level. The motion of a projectile can be analyzed using basic kinematic equations. The vertical and horizontal components of the projectile's motion are treated as separate one-dimensional motions. For example, if an object is launched at an angle theta above the horizontal with an initial velocity v0, the initial velocity can be broken down into its horizontal component v0x and vertical component v0y using trigonometric functions. v0x equals v0 asterisk cos theta. v0y equals v0 asterisk sin theta. The horizontal distance traveled, range, and the maximum height reached, projectile's peak, can be calculated using the equations. Range equals v0 asterisk v0 asterisk sin 2 theta slash g. Maximum height equals v02 asterisk sin 2 theta forward slash 2g, where g is the acceleration due to gravity, approximately 9.8 meters per square second on Earth. Projectile motion is a fundamental concept in physics and has numerous practical applications, such as in ballistics, sports, and engineering. It provides valuable insights into how objects move under the influence of gravity alone and is essential for understanding various real-world phenomena.